We are going to solve some equations today, some quadratic equations, and we're going to do so by finding square roots. So a quadratic equation, what is it? Well, it's an equation that can be written in what we call standard form. So that's one key word there, standard form. And standard form is when you write your x squared term and the number in front plus your x term plus your constant equals 0. It needs to be equal to 0. So writing it in descending order of the powers and making sure it's equal to 0. A cannot be 0, and A is also called the leading coefficient. So the number in front of the x squared in a quadratic equation is called the leading coefficient. So today we're going to assume the b term is 0. So really we're going to start with what you see there is some number squared equals another number. They're not really quadratics because we would need to subtract 16 in the first example from both sides. So x squared minus 16 equals 0. Then it would fit the standard form. We will have ones that look more like standard form as we continue to go out through a chapter. But to solve using square roots, this is what we can start with today. Now to get x by itself, it's x squared. To undo a square, we take a square root of both sides. So x equals, and remember when we take the square root of 16, because it's x squared, we get two numbers, positive and negative 4. Positive 4 squared is 16, negative 4 squared. If we plug 4 in here, 4 squared is 16, and negative 4 squared is 16. Same thing with the next example. Take the square root of both sides. That means n is going to equal the plus and minus the square root of 11. So the square root of 11 is approximately 3.32. So positive 3.32 squared is 11 and negative 3.32 squared is 11. The next example here, square root of both sides. So we have z squared equals 144. So that means z is going to equal plus or minus the square root of 144, which is 12. So z is equal to positive 12 and negative 12. With the next example, it's similar. Take the square root of both sides, but we run into trouble here because we can't take the square root of a negative number. So we have to say that there are no real solutions. We can't take the square root of a negative 4, so there is no number we can plug in for x that we currently know that can get us negative 4. If we continue down, now we have something that looks more like a quadratic. 6x squared minus 150 equals 0. So we need to solve for x. So what we're going to do is get rid of everything beside the x squared and then treat it like the previous slide. So we're going to add 150 to both sides. So the goal is maybe not so much to get x by itself, but to get x squared by itself right away. So we have x squared equals 25 after dividing by 6. Now we can take the square root of both sides. And again, we're going to get two answers as x is equal to positive or negative 5. So now to check our work, we could plug in positive 5, make sure we get 0, and plug in negative 5 to make sure we get 0. The next example here, we need to divide by 4 to get the x squared by itself. So make sure everything gets moved over to the other side before you take the square root. Like in the previous example, we had to move the 150 and the 6. This time we need to move the 4. So again, we get x squared equals 25. Take the square root of both sides. We get x is equal to positive or negative 5. And again, the last example here on this page, add 4 to both sides to try to get the y squared by itself. Divide by 3. So y squared is 5. So we can take the square root of both sides. So y is equal to plus or minus 2.24. So make sure when you see an equation with y squared that you get two possible answers, plus and a negative. Falling objects. We can have a quadratic model that represents that. Their height is equal to negative 16 t squared plus s. H is going to be the height at a given time, at time t. So if I plug in t is equal to 1 second, I can figure out how high the object is then. S is going to be my initial height, or the height that I start at when I drop the object. So, in this example here, construction trash falls 25 feet into a dumpster. Write a model for the height of the debris. So I want to be able to say how high is in 1 second, 2 seconds, 3 seconds. But I really want to know how long will it take the trash to hit the bottom of the dumpster, right? So the height is equal to negative 16 t squared plus s, which is the initial height. The trash is falling from 25 feet. Now, I want to know when it hits the bottom of the dumpster. Essentially, then I'm hitting the ground. So I want to know when the height is equal to 0. So we now have our quadratic equation. I could subtract 25 from both sides. Right. So I'm solving for time. And I want to know how long before it hits the ground. So divide by negative 16. Negative 25 divided by negative 16 is 1.56. Take the square root of both sides. Now notice I didn't do a positive and negative here, because if I throw the trash out, it's not going to hit the bottom in negative 1.25 seconds. It's going to be a positive. So here's where you only do get one solution. So if you throw it out that window or door in 1.25 seconds, it'll hit the bottom of the dumpster. Here's another example. Do not try this at home, unless you have a cliff with a big pool underneath it. So a cliff diver jumps from an 84-foot cliff. And he's jumping into a big, deep thing of water. Write a falling object model for the diver's height above the water. So the height is equal to negative 16 t squared plus the initial height, which is 84. And we again want to know when he hits the water. So we want to know when it's equal to 0. So we're going to start by subtracting 84 from both sides again. So we get negative 84 is equal to negative 16 t squared divided by negative 16. So negative 84 divided by negative 16 is equal to 5.25. Again, here is where if I take the square root of both sides, I only want the positive number, 2.29. So it takes 2.29 seconds to fall from the top of the 84-foot cliff into the water.